For the take me out to the ball game problem, we have the baseball diamond, and the question is which base is closest to the pitcher's mound. And so pitcher's mound is located somewhere in the line between home plate and second, and so we're told that it's 60.5 feet from home plate, so wherever that is, somewhere in here, pitcher's mound. Okay, now the baselines are 90 feet apart, and the baseball diamond is a perfect square. And so the things to point out here, we need to know where the pitcher's mound is first. And so if we look at the distance from home plate to second base, we can find that using the Pythagorean theorem. And applying that to the right triangle from home to third to second, say, we end up with 90 squared plus 90 squared equals that diagonal from home to second squared. And so that's 90 squared is 8100, so 2 times 8100 is that diagonal squared. And so that means that diagonal is equal to the square root of 2 times 90. But if we want to think about where that pitcher's mound is it halfway? Is it less than halfway? And so if we think about, let's put it in, it's going to turn out to be about right there, say. And so let's put that in. And so the distance we know from the home plate to the pitcher's mound is 60.5, and that's given. And so if we double that and think about what twice that distance would be, and so if it's less than half, and that twice that will be less than the diagonal. If it's more than half, twice that will be more than the diagonal. And so we know how long that diagonal is. So let's compare. And well, doubling 60.5 is 121. And squaring that, we get 14,641. If we compare that with the diagonal squared, that's 16,200. And so double the distance from home plate to the pitcher's mound is less than double. Well, it is less than the full diagonal, and so that 60.25 or 60.5 feet is less than half of the distance from home to second. Okay, so here we go. Now let's draw in some triangles, and one thing to note is because that diagonal cuts the square into 2 congruent triangles, that 90-degree angle is bisected, and so the angle from third to home to the pitcher's mound is 45, and similarly we have the third to second to the pitcher's mound is also a 45-degree angle. And so those are drawn in red. Another thing to note is the distance from home to the pitcher's mound is less than the distance from third base to the pitcher's mound. And we're going to prove that by comparing angles. And so a key idea is that in any triangle, side lengths correspond with angle sizes. And so in any triangle, longer sides are opposite greater angles. And so this is actually Proposition 20 out of Euclid, Book 1. Whereas the Pythagorean theorem is 47 in that same book. So we've got the triangles over here, and so thinking about this, we want to compare the distance from home to the pitcher's mound with the distance from the third base to the pitcher's mound, and so we want to see that the home to pitcher's mound is less, and so if we look at the angles opposite, angle A is opposite the home to the pitcher's mound, whereas that 45-degree angle is opposite the third to the pitcher's mound. So if we can prove that angle A is less than 45, then we've shown that distance from the pitcher's mound to home is less than the distance from third to the pitcher's mound, which we know is, of course, less than the 90-degree side. So yeah, what's the key here? Well, angle A is less than angle D. Why is that? Well, this is based on our key idea. And this would be great to use with like ang legs, for example. Suppose we will think of this as, I want to think of these as like the same kind of triangle we're trying to construct. We've got the 90-degree length, and then we got a 45-degree angle, and then we're comparing, trying to build these other sides to compare those triangles. And so because the distance from the pitcher's mound is less than the distance from second to the pitcher's mound, if we compare the sides opposite, side opposite D and the side opposite A, and they have the sort of side angle, so we would be building that same side. So sorry about the dotted line here, we really are comparing these two. And because this is more, that means angle D is greater than angle A. Okay, so we compare those, and because angle A and D add up to 90, and angle A is less than angle D, it means that angle A has to be less than 45 degrees, which now finishes our proof. Take care.